Hi there. This is my presentation for my content track project in the Educational Technology course with Georgia Tech's Online Master's Science and Computer Science Studies. My main goal was to develop an online data science course to cover customer analytics techniques. I'm going to overview the materials, cover the topics, and outline the future steps for my courses. I will cover 6 sections in this presentations. First, I'm going to talk about the available resources and the GitHub repositories that I created that contain the course materials. Then I'm going to cover each of the 4 topics for the Customer Analytics course in sections 2 through 5. And finally, in section 6, I will give a brief introduction to my future goals for building an online practical business-oriented data science courses. The material for the course is stored as a Python Jupyter notebooks. Each of these notebooks is located in the code folder of the repository and contains the required datasets. The notebooks are meant to self-serve as a self-sufficient learning tool which students can use without the instructor. If you have any comments or advice about the notebooks, feel free to ping me. The data we use comes from University of California Irvine Machine Learning Repository. It has customer transactions from an online retailer coming from multiple countries, yet majority of the transactions are from the United Kingdom. Since the dataset contains outliers and missing values, I have created a separate repository to clean it and then use the outcome in the other courses. You can check out the data preparation and cleaning rules in the first GitHub repository. First topic that I want to cover is cohort analysis. What is very convenient with this approach is that it allows to use simple descriptive techniques to uncover actionable insights. Cohort analyses are very popular with startup companies where they need to track customer activity with product improvements over time. The so-called vanity metrics, when companies track customer activity in an aggregated way, do not provide insight whether customers who are acquired at a time when product is improved are more likely to stay with the company longer and use the app or product more. Cohort analysis breaks down customers into cohorts that are either time-based, such as acquisition day or acquisition month, or segment-based, where we group customers by their specific attributes like being a member of a loyalty program, and finally size-based, where we group customers into cohorts based on the magnitude of their purchase or activity. Association rules mining is a second topic, and it's a descriptive data mining technique that helps to find relationships between products that are being bought together and then determine the strength and the so-called interstringness of that relationship. It allows to identify pairs of products that should be sold together or put into shelves close to one another if we're trying to optimize placements in the physical store. The RFM segmentation. So this chapter covers the traditional descriptive segmentation method of recency, frequency, and monetary value, which is also known under its acronym RFM. Although there are many challenges and shortcomings of this technique, as it has been used for decades before modern data mining and machine learning methods enabled marketing teams to make better predictions about customer behavior, it is still a very widely used descriptive technique in many corporations and has multiple applications. Not only it provides marketing teams to build customer segments in an easy and interpretable way, but also enables marketing teams to customize marketing campaigns for their customers. Also, we will use the values calculated in this section to build customer segments in the next chapter using k-means clustering. Final chapter is customer segmentation with k-means. K-means is one of the most popular clustering algorithms and is being used in multiple fields, from business to medicine to many other fields. In this chapter, I will show how to use previously calculated recency, frequency, and monetary value metrics to build customer segments using k-means clustering. We will uncover interesting segments with different attributes that will give us a better understanding of the distribution of the customer base. Finally, we will touch upon feature engineering, where we will build multiple behavioral attributes like tenure and monthly average spent, which can also be used in k-means clustering and uncover different types of segments. As the GitHub repositories have been already developed and completed, my next steps are to develop an online course with DataCamp, with whom I have already signed a contract. The first course will be called Customer Segmentation in Python and is due to be released approximately in November this year. We have also discussed with DataCamp several other courses once this one is released. I plan to further develop courses on advanced feature engineering, where I will show tips and tricks on data preparation for machine learning. Feature engineering is a data preparation in a format that calculates multiple ratios and gradients to record changes in customer behavior, emphasize product mix, magnitude of usage, and multiple other behavioral aspects. The next step is building a course as a follow-up to the feature engineering course. It will utilize the features and target variables developed there to teach students the practical aspects of the machine learning for marketing applications. While there's a lot of material in online courses on the modeling side, there is still a gap on covering the traditional marketing next best action models that focus on predicting multiple customer behaviors frequently and then choosing one with the highest probability. Finally, my goal is to develop courses in my own website, cyborgs.com, which currently only has several blog posts, but I have a vision to develop it into a fully fledged online data science academy. That's it for my presentation. Thank you very much and good luck.